Moonshot has announced Kimi K3 with 2.8 trillion total parameters, native vision, and a 1 million token context window. Those numbers are extraordinary, but they need translation before celebration. Moonshot calls K3 an open 3T class model, yet the full weights are promised by July 27, 2026. Today, that makes openness a scheduled deliverable, not completed access. The 2.8T figure describes the entire parameter pool. K3 uses mixture of expert sparsity, so every token engages only a small routed subset rather than the whole model. Moonshot says K3 activates 16 of its 896 experts. That reduces per token computation relative to activating everything, but it does not shrink the complete weight collection. Think of MoE routing as a switchboard choosing specialists for each token. The useful question is not merely model size, but whether routing selects the right expertise reliably. The routing system is named Stable LatentMoE. Moonshot presents it as part of K3's sparse architecture. Independent testing must show how stable and effective that routing actually is. Kimi Delta Attention, shortened to KDA, is another headline component. Moonshot associates it with K3's long context design, but the launch summary alone does not prove practical recall quality. A 1 million token window means the interface can accept an enormous sequence. It does not guarantee that one clue buried halfway through will influence the final answer correctly. K3 also includes attention residuals, or AttnRes. It is part of Moonshot's architecture story, although its contribution should be separated from the performance claims of the complete system. Moonshot's stack further names gated MLA, SiTU, and per-head Muon. These labels matter to researchers, but names alone are not evidence of better applications or cheaper deployment. The published context framing is 1 million tokens, with another release note specifying 1,048,576. That scale could hold large repositories, documentation sets, logs, and lengthy agent traces. Long context is capacity, not free intelligence. More input can increase latency and cost, while irrelevant material may distract the model unless an application retrieves and organizes information carefully. K3 is presented as natively visual, not merely a text model with an unrelated image tool. That could matter when agents must reason across screenshots, diagrams, and interfaces. Native vision still needs task-level evaluation. Reading a button label is different from understanding a dense chart, locating a visual bug, or operating software without costly mistakes. Moonshot positions K3 for long-horizon coding and knowledge work. That is a product claim, not permission to assume reliable repository changes, passing tests, or sound architectural judgment. Agent workflows magnify both strengths and errors. A model that plans well can save hours. One confidently taking the wrong branch can spend tokens while damaging its own progress. Moonshot explicitly lists sensitivity to thinking history as a limitation. In practice, earlier reasoning context may influence later behavior, making prompt state management especially important for long-running agents. The company also acknowledges excessive proactiveness. For an agent, initiative sounds attractive until it edits an extra file, expands scope, or performs an action nobody requested. Moonshot even reports a user experience gap versus Claude Fable 5 and GPT 5.6 Sol. That unusual candor matters because capability and dependable product experience are different layers. Before weight deployment becomes practical, most builders will encounter K3 through an API. The official price separates cached input, fresh input, and generated output into very different tiers. Cached input is listed at 30 cents per million tokens. That is compelling when repeated prefixes actually hit the cache, but application design determines whether that discount applies. Cache miss input costs $3 per million tokens, 10 times the cached rate. Frequently changing context or poorly reused prompts can therefore erase the headline input bargain. Generated output is listed at $15 per million tokens. Verbose reasoning and looping agents can make output the dominant line item, even when the initial prompt is cheap. At listed rates, 1 million uncached input tokens plus 1 million output tokens totals $18. Real jobs vary, but the arithmetic exposes why efficient agents still matter. OpenRouter lists the same $3 input and $15 output rates, while warning that upstream capacity may be limited. Availability can matter as much as benchmark quality in production. OpenRouter also says reasoning effort currently supports the maximum level by default. Builders should verify controllability because always-on deep reasoning may affect latency, output volume, and cost. Now, the local AI reality. Moonshot recommends deployments with 64 or more accelerators. Sparse activation lowers active computation, but a 2.8T weight pool remains an infrastructure-scale object. Open weights can enable inspection, modification, and independent hosting, depending on the final license and files. They do not automatically produce affordable hardware, mature runtimes, or laptop inference. Even aggressive numerical formats do not make trillions of parameters disappear. Storage, accelerator memory, interconnect bandwidth, routing, and serving software all become parts of the deployment equation. Moonshot reports quantization-aware supervised fine-tuning with MXFP4 weights and MXFP8 activations. That signals low-precision deployment planning, but it is not proof that ordinary consumer GPUs can host K3. If full weights arrive July 27th, as promised, researchers can inspect architecture details, test serving strategies, evaluate quantization, and measure behavior without relying entirely on hosted endpoints. The word open carries practical questions. Builders should read the final license, usage restrictions, redistribution terms, and model documentation before planning products around an unreleased weight package. Launch comparisons are useful leads, not final verdicts. Coding agents need reproducible tasks, controlled tools, cost reporting, failure analysis, and human review, not one triumphant aggregate number. For most developers, the sensible near-term path is API experimentation on bounded tasks. Measure answer quality, token usage, latency, cache behavior, and intervention rate before trusting autonomous loops. Local builders should still pay attention because open frontier weights can seed research, tooling, and datasets. The desktop benefit often arrives indirectly, after the giant model teaches the ecosystem. A smaller model could potentially learn from K3-generated data or teacher signals, subject to licensing and rigorous filtering. Distillation trades raw breadth for a deployable, focused capability envelope. Community quantization may reduce memory and serving costs once weights exist, but quality losses and hardware support must be measured. With 2.8T total parameters, compression alone faces brutal arithmetic. Kimi K3 may be a major open model milestone, but not a home lab miracle. Watch the July 27th weights, independent tests, license, and smaller descendants. That is where the local story begins.